Namaste, welcome back to the session of turbo machines. In the previous classes, we have gone through the general analysis of turbo machines, and in the next module, we have specifically seen steam turbines, and we have analyzed the steam turbines also. In the steam turbines, we have used a fluid to run the turbine as steam. I mean, the steam is the fluid which was used as the working fluid. Now, in this session, we will be moving on to the next module, which is module number 4 in our syllabus, which is nothing but hydraulic turbines. Here, hydraulic in the sense the working fluid which is used to run the turbine is liquid. In almost all cases, this working fluid will be water. So, this hydraulic turbines can also be called as water turbines specifically. In very rare situations, we are going to use other fluids to run the turbines, but in our syllabus, we will be making use of water as the working fluid, and then we can call it as a water turbine also. So, in this entire module, we will be studying the water turbines. It is very clear here, the turbine which is run with the help of the water. So, now we have seen turbine classification in the previous sessions. Here also, based on the action of the fluid with the turbine, the turbines are classified into two categories. One is impulse turbine, second one is reaction turbine. Very first one is impulse turbine. Impulse in the sense sudden force which is acting on the blades of the turbine. If the sudden force is responsible, if the impulse action of the fluid is responsible for the rotation of the blades as well as for the generation of the power, then we will call such a machine as impulse turbine. In water turbines, the impulse turbine consists of Pelton wheel. I mean, Pelton wheel is the example for impulse turbine. Second thing is reaction turbines. Here, the reaction of the water which is leaving the blade will be responsible partly. Along with that, impulse action of the fluid is also responsible for the rotation of the blades. That means, along with the impulse action, the reaction will also be responsible for the rotation of the blades of the turbine. That is why these category turbines are considered as reaction turbines or reaction kind of hydraulic machines. Under this category, we have two different turbines in our syllabus. So, Francis turbine is the one and the Kaplan turbine is the second one. Let us try to understand the signs with which the blades are going to rotate in both kind of the machines, and then we can enter into the specific topic. So, now we are very clear, the impulse action is nothing but the sudden force which is acting on the blades of the turbine. The example for impulse machine is a Pelton wheel. In case of Pelton wheel, what happens? The head or the potential energy possessed by the water will be completely converted into kinetic energy in the stator of the machine. In case of Pelton wheel, the stator is nothing but nozzle. In the stator, I mean in the nozzle, the head possessed by the water, I mean the potential energy possessed by the water will be completely converted into kinetic energy. That means entire potential energy, or you can call it as a pressure energy of the water, will be completely converted into kinetic energy in the stator. Then a high velocity jet of water or a stream of water will be passed over the blades of the turbines. That means pressure energy conversion is completely happening in the stator itself. On the rotor, no pressure energy conversion is happening. So, it is a atmospheric pressure. I mean, the fluid possesses atmospheric pressure while it is flowing over the rotor, I mean the blades of the turbine. That means no pressure change of the fluid occurs over the blades of the turbine in case of Pelton wheel. That means complete pressure energy is converted into kinetic energy in the stator, and kinetic energy will be responsible for the generation of the power. No pressure energy changes while the fluid is moving over the blades of the turbine. So, this kind of action happens in impulse machine. The example for impulse machine in case of hydraulic turbines is Pelton wheel. Whereas, in case of reaction turbines, the stator, while the fluid is moving over the stator, part of the pressure energy possessed by the fluid will be converted into kinetic energy. Make sure here it is part, in the sense complete potential energy will not be converted into kinetic energy in case of reaction turbine. Only part, remaining pressure energy will be converted into kinetic energy, as well as this kinetic energy will be utilized to run the turbine in case of rotor. I mean, while the fluid is flowing through the rotor, part is converted into kinetic energy in the stator, and remaining pressure energy will be converted into kinetic energy, and then this kinetic energy will be utilized to generate the power in the rotor. That means this pressure energy possessed by the fluid, I mean the potential possessed by the fluid, will be converted or will be utilized by both stator as well as rotor in case of reaction turbines. That is why these machines are termed as reaction. This reaction is going to happen in the rotor. Under this category, we have two different turbines. First one is a Francis and the second one is Kaplan turbine. These two are the best examples for reaction type of hydraulic machines. So, now it is very clear, pressure energy possessed by the liquid, which is nothing but the water, needs to be extracted by both stator blades as well as rotor blades in case of reaction machines. By keeping this in mind, we can move on to our next concept. In this session, I will be talking with respect to the reaction turbines, the second part. In that reaction turbine, we have two examples, one is Francis turbine and one is Kaplan turbine. We need to analyze the working of these two turbines under reaction turbines, and along with that we need to go through the velocity triangles of those two turbines. I have taken the first thing, which is nothing but Francis turbine. So, here Francis is nothing but the name of the scientist, an American scientist whose name is J. Francis, who has proposed the first reaction kind of hydraulic machine, and hence the name has been given to this machine as Francis itself. That is why this machine is considered as the Francis machine, I mean Francis turbine. So, now what kind of turbine it is, let us initially decide, and then based on that let us look on to the working principle of Francis turbine. If we are very clear on the working principle of the turbine, then we can easily draw the velocity triangle for a particular turbine, and then we can go through the turbo machine aspects of this particular machine. So, now this is the one kind of classification of the turbines based on the action of the fluid, impulse as well as reaction turbines. While dealing with the classification of the turbines, we have gone through various other classifications also. Based on the head available, the turbines are classified into high head turbines, medium head turbines, low head turbines. Along with that, based on the speed, the turbines are classified into high speed, medium speed as well as low speed turbines. Based on the action, I mean what kind of action of the fluid is there with the rotor blades, the turbines are classified into radial flow turbines, the tangential flow turbines as well as axial flow turbines. Various other classifications are also there. In those classifications, under what category this Francis turbine falls into? Let us look on to that. So, it is a radial inward medium head mixed flow reaction turbine. So make sure we know it is a reaction turbine. This is what the action which takes place in case of this turbine. It is a radially inward flow machine, medium head, I mean the turbine operates under a medium head and the mixed flow is going to happen. That means mixed flow in the sense two types of flow is happening inside the device itself. Very first thing is radial inward already mentioned. So radial inlet, and while the fluid is moving out, it will be flown out through the machine in the axial fashion, axial outlet. Since these two types of flow is there inside the machine, this machine is considered as mixed flow machine. So now while we are talking with respect to the Francis, it is very clear it is a medium head reaction type radially inward mixed flow turbine. By keeping that in mind, let us try to look onto the turbine schematic sketch and we can analyze how the fluid is going to impart the energy to the machine's components and then power is extracted from the fluid. This is the schematic representation of Francis turbine. Before looking on to the various parts and the analysis, how we have drawn this sketch, that needs to be understood. Make sure this sketch is drawn on a horizontal plane, in the sense the turbine shaft, the center portion is the shaft, turbine shaft, this shaft is vertical to the ground. It is like this and then the turbine is mounted in this fashion. That means I need to look this from the top. It is nothing but the aerial view. What I have written on the board is nothing but the aerial view by keeping shaft in a vertical fashion to the ground. This is nothing but the top view of the Francis turbine and we have made shaft vertical to the ground. So that is what is the position of the sketch. Now let us look on to the various parts it has. This is the entrance of the fluid to the turbine. We have a ring over here. These rings are provided with guide vanes and we have a disc. To this disc number of vanes are attached. These vanes are considered as moving vanes and entire this portion itself is considered as the runner or rotor part, and make sure these guide vanes are nothing but the stator part. Stator in the sense a static component of the turbine. Next, this is the disc. This is the disc to which number of moving vanes are attached and center portion is nothing but the shaft. Along with that, this entire wheel structure is provided with the casing. This casing is considered as the scroll casing. This scroll casing is also termed by other names such as spiral casing as well as volute casing. Why those two names, we can discuss that at the later stages. So these are the various parts that a Francis turbine is consisting of. Now let us try to understand how the fluid is going to impart the energy to the blades of the turbine and then how energy is extracted and converted into power. This is the entry. The fluid is entering into the machine through this. While entering into the turbine, the fluid possesses both kinetic energy and pressure energy. That means this fluid which is entering into the machine is possessing pressure energy and kinetic energy. Both the energies are present in this fluid. Now it is entering into the machine. Now we need to understand what happens in this wheel. Once it enters into the casing, it initially enters into the set of guide vanes. Say for example, fluid is entering over here. In the sense, this is the passage that is present in between two guide vanes. These are the guide vanes. Make sure these guide vanes are not going to rotate. Fluid enters into this portion. So this is how fluid enters into the moving, a disc. So now these guide vanes are going to guide the fluid towards moving vane. And then the fluid strikes the moving blades. That means the fluid is going to impart the energy to the moving blades, and then these moving blades are going to rotate. Since moving blades are rotating, this disc rotates and this disc is attached to the shaft, thereby shaft rotates. So this is what is the outer working principle, outline of the working principle of Francis turbine. Now what happens while the fluid is entering into the guide vanes, and what happens while it is passing through the scroll casing, and what happens while it is moving over the moving blades, that has to be understood. Now we knew how the fluid is entering into the machine. Now we need to look onto individual components functioning, how individual components are functioning to extract the energy from the fluid. Now let us look onto the individual components and why they are like that and their functions. Okay, now let us try to understand the functioning of individual components of the Francis turbine. The entire blade structures are covered with the casing. That casing we have called it as a scroll casing. Here if you look onto the scroll casing shape, from the inlet the scroll casing cross sectional area is gradually reducing. That is how the scroll casing has been mounted over the blade structures. There is a reason for that. Let us try to understand that reason. Once the fluid is entered into the machine, it will enter into the passage provided in between the guide vanes. Here the mass flow rate of the fluid, if you look on to the mass flow rate of the fluid over the, while the fluid is passing through the scroll casing, more fluid will enter into this portion, and while the fluid is coming at bottom portion, the mass flow rate of the fluid gradually decreases. Here more amount of fluid will entering into the passage which is there at this portion, and gradually the mass flow rate of the fluid starts to decrease. But we need to keep the mass flow rate constant in order to provide the same mass flow rate of the fluid through all the passages which are provided by the guide vanes. The passage is provided in such a way that the cross sectional area of the passage is reducing. We need to make sure the mass flow rate should be constant, which is given by rho A into V, where rho is the density of the fluid, A is the area through which the fluid is flowing, V is the velocity. At the inlet portion, if I look onto the area, scroll casing area is huge. At the inlet, area is huge, in the sense velocity is little bit of less over there. And if you go on looking onto the area provided by the scroll casing for the fluid, the area is gradually reducing. That means, again I will take rho AV, this is at the inlet portion, and this is actually almost at the exit. Here exit in the sense at the end of the scroll casing area. Area is reduced, in the sense velocity of the fluid should increase. That is happening in order to make sure that the same quantity of fluid is entering through the passages which are present in between set of guide vanes. So that is why this scroll casing area is gradually reducing over the passage. So now this rho AV will be equal to rho AV at the exit portion of the, at the end portion of the scroll casing. So that is what is the reason behind this scroll casing decrease in cross sectional area. It is a closure cover for the turbine blades. That means the entire turbine blades are operating under, inside the scroll casing. So that is what is the second functioning of the scroll casing. It has to make sure that the same quantity of liquid is entering through the set of guide vanes. So that is related to the scroll casing, and it is also called by the name spiral casing. Why it is considered as the spiral? If you look onto the casing section, it will go in the fashion of spiral, in the sense a round fashion from starting to end. It is going in a form of spiral. So that is why that casing is also considered as spiral casing. So that is related to the spiral casing. Next thing is guide vanes. These guide vanes are nothing but the stator component. Now let us look on to the guide vanes now, concentrate on the guide vanes. These are the guide vanes. Now the fluid which is entered into the turbine passes through the passages which are present in between the guide vanes. If you look onto the area present in between the guide vanes, this area is gradually reducing. This gradual reduction in the area is going to increase the velocity of the fluid, velocity of the water. Here what happens? Part of pressure energy is going to convert it into kinetic energy because of the passage which are present in between the guide vanes, or we can say the shape of the guide vanes is going to convert part of the pressure energy possessed by the fluid into kinetic energy. That means the fluid velocity, the fluid is accelerated, its velocity is increased. So that is what is the first functioning of guide vanes. If I look on to the second function of the guide vane, at proper angle it has to discharge the fluid into the rotor, the runner vanes. Now if you look onto the sketch clearly, the fluid which is moving from the guide vane passage to the runner passage has to be at certain angle. The guide vanes are attached to the disc in such a way that each of the moving blade is receiving the fluid in that particular angle only. That fluid discharge at this particular angle has to be taken care by the guide vane itself. That is why it is called as the guide. It is guiding the fluid, it is guiding the liquid towards the moving vanes. That is why these are considered as guide vanes. And make sure these guide vanes are not going to rotate, they are fixed. Because of that, these guide vanes are also called as stator component of the turbine, because they are not going to move. Their functioning is to guide the fluid, their function is to increase the velocity by reducing the pressure partially. So this is related to the guide vanes of a turbine. Along with that, one more thing is that these guide vanes are pivoted to a point, and these guide vanes can be tilted to the required angle. In whatever angle we need the fluid to enter into the moving vanes, to such angle these guide vanes can be tilted. That is what is the advantage of guide vanes. We can tilt them along the, at that particular portion, pivoted portion. So that is what is related to the guide vanes. Next portion is, next part is rotor or runner. The name itself indicates the rotor or runner is a device which is the moving component of the turbine. That means the blades which are attached to the disc are going to run upon the fluid impinging on the blades of the turbine. This entire circle which is written in blue color is considered as the runner or rotor, because that is what is going to rotate upon the fluid strikes the blades of the turbine. Now this runner consists of a disc, a center hub to which number of vanes are attached, and at the center we have the shaft of this disc, and these vanes are going to rotate upon fluid impinges on that surface. This rotating blade is going to cause a rotation to this disc, and hence the shaft is also going to rotate. So now we need to look on to the way with which the fluid is striking the blades. Now let us take one portion. This is the portion from where the fluid is entering into the moving vanes. This is the passage in between the guide vanes, and this is the passage in between the moving vanes. Now the fluid is entering in this fashion. This fluid which is entering into the moving blades, which is entering in a radial inward fashion. It is moving in a radially inward fashion towards the center. Along with that, this can also impinge a tangential force on the blades. That means both the radial entry as well as, radial forces as well as tangential forces are acting on the moving vane to rotate it. So these two forces are responsible for the moving vane, and then we need to look on to the remaining pressure drop. Here part of the pressure energy possessed by the fluid has been converted into kinetic energy. That kinetic energy increment has to be absorbed by these moving blades. That means what? Kinetic energy is converted into work, and pressure energy is also converted into kinetic energy, and then it is also converted into work. Why it is so? Pressure energy is converted into kinetic energy. If you look onto the passage area, it is also gradually decreasing towards the center. For a subsonic incompressible flow, gradual decrement in the area is going to increase the velocity. That means pressure energy gets converted into kinetic energy. This kinetic energy of the fluid will be absorbed by moving vanes. That moving vanes are going to get us the work. That means the head possessed by the fluid, entire pressure energy possessed by the fluid has to be converted into work in the moving vanes. So that is what is the functioning of moving vanes. And here make sure the forces are nothing but radial and tangential forces. These are responsible for the rotation of the blades of the turbine. Then we have shaft. The shaft which is at the center is going to rotate because of the moving vanes. So now in the rotor, complete head, complete pressure energy possessed by the fluid will be converted into work, and then work will be converted into power. So this is how the fluid energy gets converted into work. So these are the few parts of this turbine. Along with that, one more important part is there. We have not shown it over there. Let me show it now. The fluid, upon striking the blades of the turbine, has to be discharged into the atmosphere through draft tube. We have one more device here, which is nothing but draft tube. So let me write the next device, very important device, which is nothing but draft tube. Now, we have called this turbine as a mixed flow turbine. In that mixed flow, two of the flows were included. One is a radial inward and the other one is axial exit. Because of these two movements, this machine is considered as mixed flow machine. If you look on to the entry of the fluid to the machine is radially inward. From the outer circumference of the wheel to the center part, it is a radially inward. Radially inward in the sense along the radius of the circle, it is entering into the circle, radially inward. And one more thing we have to observe here is the entry portion of the machine is too far from the axis of rotation. This entry portion of the fluid is too far from the axis of the rotation. That is what it is, a radial inward. That is why it is considered as a radial inward. Next, if you look on to the exit, here I am calling it as an axial exit, in the sense what? The fluid which has strikes the moving blades has to leave the turbine in an axial fashion. Axial fashion in the sense, I know the shaft is perpendicular to the ground. The shaft axis is nothing but perpendicular to the ground. The fluid which strikes the blades of the turbine, say this is the circle runner portion, the blades are attached to the runner, the fluid is radially striking the blades of the turbine. Once it comes into the center, it has to go axially out of the turbine. That means this is the axis in the sense it has to flow in this direction, perpendicular to the bore direction in order to exit the turbine. Once it comes out of the turbine, that means the exit is axial, then it has to be passed through the draft tube into the tail race, or we can call it as a atmosphere. If you look on to the draft tube is gradually increase in cross sectional area. So here is water is entering in an axial fashion into the draft tube, and this is the exit of the draft tube. Draft tube has a portion of a gradual increasing cross sectional area. There is a purpose for that. We have a purpose for draft tube portion. We knew the fluid which is coming out of the turbine is coming with certain velocity. The velocity of the fluid at the exit of the turbine is not equal to 0. The absolute velocity is still remain in the fluid. Let us say that velocity as V2, exit velocity, the entry velocity as V1. V2 is the velocity with which the fluid is entering in, coming out of the turbine and then entering into the draft tube. Here we need to understand, this V2 is the energy possessed by the liquid. How much the value of fluid velocity at the exit is less, that much amount of energy is utilized by the turbine. In the sense, the velocity of the fluid at the exit should be as minimum as possible. That means the fluid, the machine has utilized more amount of velocity, the energy possessed by the liquid. If it has to happen so, that means what? We need to have V2 as minimum as possible. If it has to happen so, we need to provide the draft tube. So draft tube function is to minimize the V2 velocity at the exit as minimum as possible. How that happens? That happens because of gradual increasing cross section area of the draft tube. This is what we have seen in the scroll casing also. Let us apply the same analogy here also. This is the V2 with velocity of the fluid at the exit of the turbine and the velocity at the entry to the draft tube. This V2, with this velocity the fluid is flowing through the draft tube. The area is gradually increasing. That means what? The pressure possessed by the fluid is going to increase and the velocity will come down at the exit of the draft tube. That means the gradually increasing cross section area is going to decrease the velocity of the fluid. This decrement in the velocity of the fluid at the exit of the draft tube will make sure that the V2 is as minimum as possible. If V2 is minimum as possible in the sense, the more amount of V1 has been absorbed by the blades of the turbine itself. So, the functioning of the draft tube is to reduce the exit velocity of the fluid to its minimum extent, so that the maximum amount of energy possessed by the fluid will be absorbed by the runner. So, that is what is the functioning of draft tube. So, now these are the 4 important components of Francis turbine. We need to look onto the scroll casing or spiral casing, functioning of that particular portion, and then guide vanes, the structure of guide vanes and the function of guide vanes, runner vanes, the forces which are acting on the runner vanes, and then the area passage between the runner vanes, along with that the functioning of the draft tube. So, we have called this turbine as mixed flow because radial entry, axial exit, that is what is mixed flow, and then we have called this as a reaction type of machine because the fluid which is impinging the energy onto the blades of the turbine, while it is leaving the blades of the turbine, it is going to cause a reaction over the blades of the turbine. Because of that, the fluid, the runner starts to rotate. The fluid which is going axially outward is going to cause the forces onto the blades of the turbine. That is what is nothing but the reaction. So, it is a mixed flow, reaction, medium head, in the sense this machine is usable or applicable whenever the head available for the water is medium. We have particular range over the certain amount, for certain amount of meters this particular machine is usable, and this is what is the science behind working of Francis turbine. This is what is for the today's session, and in the next session we will look on to the turbo machinery aspects of Francis turbine. Let us meet in the next session. Namaste.